All right, Unit 2. Unit 2 is going to be our unit on trig. So, you guys have had a lot of experience with trig over the years. Starting Algebra 1, you first start doing some trig, and geometry you do more, and Algebra 2 more, and pre-calc more. It is a very common part of calculus problems, and so you got to be really good at trig. But really, the basics of trig. Probably not as hard of the not even as hard of the trig that you guys did in like algebra 2. So but you got to be really good with the basics. So this is what this whole chapter is going to be about, is getting really good at trigging. And so please commit to learning, remembering all these rules, memorizing some stuff, and just becoming really good with it. This handout has a bunch of notes on it that we're going to be kind of going over different parts of it over the course of this unit. So this is not all something you need to know today, but it is kind of a nice reference sheet. It's got the basic setup for trig, Pythagorean theorem, writing sine, cosine, tangent, so cotoa, cosecant, secant, cotangent, which these are called the reciprocal trig functions because they're the original ones upside down. Reciprocal, upside down, flip it upside down. So there's always a co with a non-co. Cosecant is one over sine. Secant is one over cosine. Cotangent, tangent, obviously go together. We're going to be going with law of sines, law of cosines later. There's some different just identities. We're going to go graphing trig functions. You got to be good at that. Inverse trig functions. Special angles, which come from special right triangles, 45, 45, 90, 30, 60, 90. You're going to probably want to memorize those. And the Pythagorean identities, so sine squared plus cosine squared equals 1, and some other versions of that. Some difference identities will maybe use a little bit. Double angle identities will use a little bit. Half angle identities probably won't even use that at all. So, anyways, back of this is the first day of notes. And so some of these things that you saw on that page, I'll probably just copy and paste onto these pages. So this is our first assignment. And let's see. So first off, we might start some of these off, draw pictures, kind of use diagrams and stuff, but eventually you're going to probably want to memorize some of these things. But one thing we could do is we could draw a picture of this angle. And it says that it goes passing through the given point. So generally, the angle is considered to be starting at the positive x-axis and going counterclockwise. And that's sort of the quadrants, quadrant 1, 2, 3, 4. So 2, 4, we could say is, doesn't need to be perfect or anything like that. This is just to help you kind of figure out where things are. So this is the angle we're talking about. In fact, it goes through this, it says. It goes through that point. So it could be any point in that line, creates the same angle. And we want to find sine, cosine, and tangent of that angle. So sine of theta equals, and so we have SOHCAHTOA, sine angles opposite of our hypotenuse. So what we're going to do is we're going to draw a right triangle in. And this side is 2, and this side is 4, because this is the x value and the y value. This right here is often referred to with an R for like a radius, because it's like a sweeping circle. So if you do a Pythagorean theorem, it'd be r squared equals 2 squared plus 4 squared. So that's 4 plus 16. So that's 20. And then you take the square root of both sides. Now, usually we go plus or minus when we take the square root of both sides, which is something I'm going to be picky about. But the radius or the hypotenuse of a right triangle is always considered positive. And we could simplify it to 2 root 5. So that's what this is, 2 root 5. Now, this is considered the opposite side. And the y value is usually the opposite side. It's across from the angle. This angle is always right here at the origin. So this is always going to be the adjacent side. The adjacent side is always sideways for when we're thinking about this on a unit on the coordinate axis. And this is the hypotenuse. So sine is opposite over hypotenuse. And we could reduce that. And we could we could rationalize the denominator, right? Cosine would be adjacent over hypotenuse. So 1 over root 5 or root 5 over 5. And tangent, the opposite over adjacent. So it'd be just 2. So anyways, basics. Now we'll do some other variations. Find cosine theta if I give you sine of theta. So last time I gave you the coordinates. This time I'm actually giving you one, and I want you to find potentially other angles. Cosine, tangent, secant, cosecant, cotangent. But we could still draw a picture and try and figure out where this triangle is. Now, sine is opposite over hypotenuse. So that means the opposite could be -2, and the hypotenuse. Now the negative is just going to be in front or on the top usually. So don't assume it goes with the top. But in this case, the hypotenuse has to be positive, right? Hypotenuse is always positive. So that's got to be positive. Now, where is the opposite side going to be negative? The opposite side is always the vertical side. So here it's positive, right? Here it's positive. Here it's negative because it's down. Here it's negative because it's down. So there are 2 places it could be. It could be this angle or it could be this angle. Now the triangles, little right triangles that we create, they get created by what's called the reference angle, which is a little angle in here. But the angles, all the angles actually start at the positive x-axis, go counterclockwise. So it's got to be one of those. The hypotenuse is 3. So we probably want to find the adjacent side, which will be the same length, but here it'll be positive and here it'll be negative because here it's to the left in the x direction, so it's going to be negative. Here it's to the right, so it's going to be positive. So Pythagorean theorem, r squared equals -2 squared plus, the r is 3, so 3 squared equals that. And we might call it x. 9 equals 4. The negative gets squared. 5 equals x squared plus or square root of both sides plus or minus. Now plus or minus makes sense. Here it's positive square root of 5 and here it's negative square root of 5. So usually what happens is if you are given a trig equation and you solve it, it's going to give you multiple answers. And you're generally responsible for all the possible correct solutions of a problem in math. So if they didn't say anything else, we would give 2 different answers. But here it says it's in quadrant 4. So this is quadrant 1, 2, 3, 4. So there is something restricting it to this one. So cosine of theta is adjacent positive root 5 over hypotenuse. But I could ask you for anything. I'd say, well, what's tangent? Tangent is going to be opposite over adjacent, right? And then we could rationalize the denominator. Okay? I mean, I could ask you for secant. Now, the way I remember secant is I remember it's 1 over cosine. Is secant. Co goes with the non-co. So then I think, okay, well, cosine, you don't have to write this, but cosine is adjacent over hypotenuse, which gives you hypotenuse over adjacent. So hypotenuse would be 3 over adjacent would be root 5. So it would be 3 root 5 over 5. or cosine flipped upside down. Anyways, if they said quadrant 3, we'd get some different signs on our answers. Now, one of the things that we do need to remember is when is sine and when is cosine, when is tangent, secant, cosecant, when are they positive or negative? Now, there's this cute little thing that I really want you to ignore, okay? And some of you guys aren't going to, but let's just cross out right now. It's just cute. All seniors take ceramics, all scholars take calculus, and trying to memorize it like that, which I think usually people try that, they mess it up. What I would do, this is what I do, and this is something we're going to also have to be really good at, is just visualize or even draw on your paper if you have to the sine and cosine curves. So here's the sine curve. Sine always starts at 0, right? Amplitude 1, negative 1. Okay, the quadrants right here, they get cut up into fourths. So this is the way we usually think of quadrants, but we could think of quadrants like this, where we graph the y value versus theta. And then that's when you get that wave graph instead of just circles. Quadrants, you divide in half, you divide the halves in half, you get quarters, quadrants. And so quadrant 1 and 2, sine is positive because it's going up, then it's below negative for quadrant 3 and 4. So we're going to be thinking of these graphs so much. This is the basic sine curve. That is something you should know by now. The cosine curve starts like this. Starts at the peak, cut it in half, cut the halves in half. So this is a cosine. This should be burned into your memory already. So this is quadrant 1, and then it goes negative for 2 and 3, and then positive for quadrant 4. Now, if you know that, that's all you need to know, because tangent is just sine over cosine. So you think, well, is sine positive? Is cosine positive? Is it positive or positive? Negative or negative? Positive or negative? Negative or positive? Whatever. If you just know these two graphs, you can do tons. So this is saying, name the quadrants in which the terminal side of theta may lie. Which quadrants could it be? And this is kind of like this compound conditionals we were doing last chapter. We're going to be doing it with trig this chapter 2. When is cosecant negative? Well, you're like, I'm not going to memorize a bunch about cosecant other than it's 1 over sine, right? So essentially we're asking, well, when is sine negative, right? Well, that's going to be quadrants 1 and 2, right? It's that first part of sine, right? And when is cotangent? Well, cotangent is first of all 1 over tangent, right? And tangent is sine over cosine, so you're going to get cosine over sine. Now, when is cosine over sine going to be positive? Well, it's going to be when they're both the same sign. They're both positive or they're both negative. Well, they're both positive in quadrant 1, and they're both negative in quadrant 3. Now, here's the deal. It's this and this, which means we got to pick where they both overlap. Which is, oh, you know what? I messed up this first one. Where is sine negative? I picked where it's positive, so it should be quadrant 3 and 4. All right. So where are both of these things true? Quadrant 3. So there you go. Something like that. Okay. Number 4, find all angles on negative 360 to 360 for which cosine theta equals negative 1. Okay, so there are infinite answers generally for trig problems because the wave keeps going forever, but we often get restrictions on where we want the answers. So we just need to find all the answers here. So I think what you should ask yourself is, this is kind of like that problem up there, right? I gave you a trig, but asked you to find another trig. But here I'm actually asking you to find the angle. You want to think of it as a fraction. And cosine is opposite over hypotenuse. So you want to think, well, what kind of triangle would that look like? You know? So the opposite side is the vertical one. So here it's positive 1, here it's positive 1, here it's negative 1, here it's negative 1. So it's got to be like one of these situations, right? But then the hypotenuse is 1 also. That's impossible. The hypotenuse has to be along the side of a triangle. right? So think, well, when would that happen? And what this would happen, that the hypotenuse and the opposite side were the same, is if you kind of think the closer this gets here, the closer they get to the same length. So it's kind of like this special case where the triangle collapses on itself straight down. Because then the opposite side and the hypotenuse are right on top of each other. The adjacent side is 0, right? Adjacent side 0, but hypotenuse is 1 and the opposite side is 1 also. What angle is that? That's 90, 180, 270, 270 degrees. That's when that happens. Now, actually, I think I messed that up. You know what? I messed that up. It's adjacent. So it's got to be the adjacent side. Okay, let's start over here for a second. The adjacent side is this one right here. So here it's positive 1, here it's negative 1. So the triangle could be here, 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 or here, but it's got to be a negative adjacent side. So it's got to be one of these, but for the hypotenuse to equal the adjacent side, it's kind of like they got to flatten right on top of each other. So the special case is right here, and that's 180 degrees. So theta equals 180 degrees. Now, that's positive 180. Negative angles start here and go backwards. So negative 180 degrees is another possible answer, but then they repeat themselves. If you add 360 to this, 540, it happens again, but then that's outside of this. So these are your answers right here. I mean, you could also kind of think of this, think of the cosine curve and say, well, here's the cosine curve, right? It goes from 1 to negative 1. And when does it hit negative 1? Exactly halfway through the period, 180 degrees. I mean, that's something you're probably going to just need to memorize. But this kind of drawing of triangles and pictures, which I think will be a good way to start with this, makes a lot of sense. It's a special case. It's like a collapsed triangle. I want to try a couple of problems from the homework. So we're going to try 22 and 11. 22 and 11. So let's see. Let's do 11. Now, like I said, let's ignore this cute little way of trying to memorize where sine, cosine, and tangent are positive and negative. That's not going to work. It's silly. You should know it from some other things that you really need to know. This is a sine curve. Positive, positive, negative, negative. Quadrant 1, 2, 3, 4. Cosine curve. Positive, negative, negative, positive. Quadrant 1 is negative. Quadrant 1 is positive. 2 is negative. 3 is negative. 4 is positive. So number 11, when is sine less than 0? Well, that's quadrant 3 and quadrant 4. So a lot of times you use Roman numerals. That's right. Cosine is negative in quadrant 2 and quadrant 3. Now the key word here is or, which is like union, which means we don't care if they overlap. We want all of them. So in quadrant 2, 3, and 4. For your final answer. Okay, number 22. So this is kind of like the last problem. When is sine equal to negative 1? These are all kind of special angles. We'll get into the other kind of angles in the next lesson. Okay, so but when is sine is opposite over hypotenuse? And you could think, well, when is the opposite side negative 1 and the hypotenuse is positive 1? So opposite side is the vertical one, right? So it's either here, it's positive 1, right? But and you know the negative belongs to the opposite side. The hypotenuse has to be positive no matter what. So here's when the opposite side is negative, right? And the hypotenuse is 1. Well, how's that possible? They got to be the same length, so it's going to like collapse on each other. They're right here. That is 270 degrees. Now here's the deal. the 2, we're ignoring the 2 right now. So whatever is in sine is going to be 270 degrees plus it happens every 360 degrees, k, or k equals an integer. I don't know if you guys remember that kind of notation in your math classes before, because this represents all the infinite answers. Then you could divide by 2, including the period right here. So that's going to be 135 plus 180k. That gives you all the answers. Well, we want the answers between negative 360 and 360. So 135. But if you add 180 to this, you get 315. That's within there. If you subtract 180 from this, you get negative 1, or you get negative 45. And if you subtract another 180 from that, you get negative 225. If you subtract another 180, you get to negative 405, which is too far, right? So there's your final answers. So I'd be starting to do work like that with representing all the infinite answers, because we're going to get some complicated trig functions, and that'll be the best way to make sure you don't miss some of them. But it's kind of what I'd be doing here on these special cases. Okay. So try the homework. It's just this one sheet. Not too bad. Some basic trig stuff. We'll get into some more trig stuff tomorrow. I gave you examples like all these problems on today's notes, so you should be pretty prepared for any of those kind of problems.